Hello everyone and welcome back to the H.I.R.O model TR-01-A tutorial series, and today we'll be talking about H.I.R.O's Cortex. This is H.I.R.O, as all of you know. Maybe you have noticed, but H.I.R.O is actually a very simplistic robot. So you have a printed circuit board here that facilitates both the electronic and structural functions of the robot. It is this printed circuit board that we're calling the Cortex. So the Cortex here is Raspberry Pi Pico based, so I designed this for two specific applications, education and prototyping. If you're learning about robotics for the first time, the best place to start is microcontroller education, because if you know how to program and if you know how to wire and design electronics, you can build a robot. It was actually very important to me that in the process of learning how to use H.I.R.O, that you learn how to essentially use the Raspberry Pi Pico here. The second application, of course, being prototyping, needed a board that made it very easy to make robots. So is the Cortex H.I.R.O specific? Well, absolutely not. If you want a board that helps you build robots, you need to be able to run higher voltage than the Pico here runs. In this case, we have 8 different 3-pin breakouts, or 1 pin for control, where it says PWM, and 1 for power and ground, and they are connected to the Raspberry Pi Pico's VSys pin. So Raspberry Pi Pico either draws power from an external battery or it draws power from USB. In the case that it's drawing power from both, the VSys pin actually chooses the power source with the higher voltage, so we can draw power from that. So if you have a battery and the battery runs at 6 volts and the USB power source runs at 5 volts, the voltage that will come through the VSys pin is actually the voltage of the battery at 6 volts. The second thing you want from a robotics dev board for prototyping is the ability to design and integrate your own electronics. So we broke out all the Raspberry Pi Pico's pins in these headers here, and one thing I didn't quite like about the Raspberry Pi Pico on its own is if you wanted to figure out what a pin did, you had to look at the documentation. And so I made the decision to label all of them on the Cortex here. And another thing you need for a dev board is the ability to quickly control your robot. So we have external buttons. You have 3 buttons here. One is a button A and a button B, and this last one is actually another improvement I put on the top of the Pico's functionality. So the Pico does not have a reset button, but it actually has the ability to reset if you short the run pin. So we have a reset button here that allows you to start the program over again. And in the case that you need to know what the robot's doing at a quick glance, we have an RGB status LED. And the last thing you need on a robotics prototyping PCB is sensors. Either you can add custom shields or wire in your own sensors here, or we have some headers for some basic sensors. So we have a header mount for a ultrasonic sensor, and it should just plug in like that. And we also have a breakout header for an MPU 6050 6-axis gyro accelerometer, so we can maintain inertial odometry. Do you have to use this to make our H.I.R.O bot? Of course not. You can use this to make your own robots. So let's run some code on our Cortex here. So usually when you define a LED, you are defining the pins. On RGB LED, so this is the RGB LED, is essentially 3 different LEDs in one casing. So you can turn on a red light, you can turn on a green light, and you can turn on a blue light and vary the power so you can get different colors. In Arduino, when you're turning on a pin, you usually have to define it as an output. So we'll say 6, which is the green light, and we set it as an output. And to turn it on, we say digital light 6, and then we set it high. High being on and low being off. Let's run this program. Give it a moment to compile. And as you can see, a green light turns on there. It's kind of bright, so don't look too directly into it. Let's replace pin 6 with pin 7. And let's run the sketch. And the red light turns on. Let's turn on pin 8. And the RGB shines blue. When we combine them together, so let's turn this to 6. And let's copy this 2 more times. And what happens when you mix red, green, and blue? That's right, you get white light. So if you're not sure what these pinouts are, you should be able to find them in the manual of your H.I.R.O kit. And if not, you can also do this. So go to Sketch, include Library, and scroll all the way down until you can find your H.I.R.O library, and click H.I.R.O. Even if you don't know the pins, we can still define them. So we say H.I.R.O, this time we'll call it Cortex, and in setup, we'll write cortex.begin. Let's choose a color. Let's choose purple. We'll turn red and blue on to make purple. Digital write cortex.blue and set that to high. Digital write cortex.red. And let's run the code one more time. And here we have purple. As you can see, we didn't have to define pins as inputs or outputs. When we wrote cortex.begin, we connected all the would-be motors. None of them are connected here, but if they had been, we connected the LEDs and the buttons. So speaking about the buttons, let's get those working. So let's write a program where if no buttons are being pressed, no lights are on. But if button A is being pressed, the red light is on. If button B is being pressed, the blue light is on. And if both buttons are pressed, the purple light is on. So I'm just gonna get rid of this right there. Make sure that we still have a bracket. If we got to do a digital read, cortex dot button A and digital read dot button B. So if both are on, digital write cortex dot blue high, write cortex dot red high. Now, if both buttons are pressed, both lights will be on. Okay, else, if all we have to do is copy this, if only button A is being pressed, we got to make sure that the light turns off. In the previous iteration, one of the lights was on. It's not enough to just turn one on. We have to make sure that any light that needs to be off is off. So, and the next line is going to be very similar. So let's just copy all of this and paste it in there. So else if button B is on, let's set that to low, and let's set that to high. And else, the last scenario is neither of the buttons are being pressed, so we set both of these to low. And else does not have parentheses. So let's let it compile. Okay, it's done uploading. So if no buttons are being pressed, the lights should be off. If you press button A, it should be blue. Yep, and it's blue. If I press button B, it should be red, and if I press both of them, it should be purple. So this is a very, very simple example, but if you need status at a glance, having an RGB LED is a great way to do that. You can also now send input into the robots using these two buttons. Anyway, thank you so much for tuning into this tutorial. I hope you keep playing with the Cortex and coming up with ideas of what you can do with it. It is up to your imagination what you can do.